The city of Bolzano, with its 106,000 inhabitants, is located in a wide, densely populated valley basin where three valleys cross. Weather conditions are influenced by the geomorphological structure of the valley basin, which affects the wind circulation that often leads to air congestion in the winter months.
As in all urban catchment areas, emissions are concentrated in a relatively small area. The emissions come from various sources: urban traffic, interstate roads, and also the highway with its heavy traffic. In addition, there are also emissions from house heating, industrial plants, and the waste recovery plant. Hence, we do have multiple emissions in a limited area, where rapid degradation is not possible.
Distribuite in una regione che non consente immediatamente lo smaltimento.
For an effective protection of the environment and health, it is essential to determine both the amount of emissions and their distribution in the atmosphere, as well as their precipitation on the ground. Computer models provide important data for this purpose. However, it's also necessary to prove the accuracy of these models by field research. To this end, EcoCenter, together with the experts in atmospheric physics at the University of Trento, the Mario Negri Institute in Milan, the Regional Agency for the Environment and Eco-Research, is conducting a land monitoring study. This is a research project which uses the waste recovery plant in Bolzano to test the distribution model developed by the University of Trento. This model is useful in scenarios such as fires or explosions where strong emissions could develop and which require targeted intervention by civil protection.
Per condurre questo studio, oltre alle misure effettuate...
In addition to measurements with existing measuring stations and our own installed measuring devices, we also developed computer simulations of weather processes and emission distributions. In addition, we felt it was important to carry out an experiment in which we released an indicator substance into the atmosphere through the chimney of the waste recovery plant. The calculation model can be backed up by subsequently collecting air samples in the environment.
In modo da avere una validazione del modello che verrà utilizzato.
For the computer simulation, which shows the concentration of the substances on the ground, we use data from various sources: large-scale weather forecasts, Eutelsat, and data from local weather stations. We apply the latest measuring instruments for the thermal profiling of the winds, such as the SODAR on the roof of the waste recovery plant and the LIDAR near the Bolzano railway station. The LIDAR provides data on wind direction and wind force up to an altitude of 2 to 3 kilometers. Based on this data, the model defines the places on the valley ground with the highest emission precipitation.
In fact, I am merging the available data to derive a forecast to understand exactly where the indicator substance from the waste recovery plant will precipitate. This allows us to target the work of the teams who collect the samples. In
February 2017, the working group identifies the perfect day to carry out the experiment, a day with stable weather conditions and no wind. These weather conditions lead to air congestion and thus represent the worst possible weather conditions for the valley basin. The disposal of the indicator substance occurs at 2 different times of the day. This also takes account of changes in wind direction during the day. The first phase of the sampling begins at dawn. 14 teams are involved, distributed among the locations calculated by the computer model.
In the second series of tests, the indicator substance is released again between noon and 1 a.m. The individual teams then follow the same procedure as in the morning. We expect stable weather conditions with low winds. The area with the highest precipitation of the indicator substance will likely be a little south of the Bolzano basin.
The inspection teams have special bottles with valves. The bottles allow the collection of air samples over a period of between 20 to 60 minutes.
The allocation of the inspection teams who collect the samples of the indicator substance was precisely planned. Main reference are those areas where the population might be directly affected and exposed to emissions. Here, possible precipitation should be measured exactly. Furthermore, the teams are distributed to locations that depend on the immediate weather conditions. The computer model can continuously calculate and adapt these accordingly.
È suscettibile di adattamento sulla base delle uscite più recenti del modello.
In the two stages of the study, an inert indicator substance which is usually not present in the air is released from the chimney of the waste incineration plant. Our task is to carry out an exact quantification of this substance in the air. At the specified time, the Eco-Research Director will introduce the indicator substance into the flue of the combustion furnace. From this moment on, the mathematical model determines where and in what concentration the indicator substance will be deposited. Sampling begins at the time specified by the calculation model. The teams equipped with bottles go to the designated locations to start the sampling. The 14 groups involved take up their positions in the various sensitive areas of the basin and thus guarantee total coverage of the area. A total of 40 sample bottles are used for the study, and additionally, the sampling systems from Istituto Mario Negri. Sampling is carried out according to the expert's instructions. In the late afternoon, at the end of the second examination phase, the samples are handed in. The analyses are carried out in the special laboratories of Eco-Research in Bolzano. The laboratory technicians use a mass spectrometer to examine the air samples.
With the highly sensitive mass spectrometers, it is possible to detect even the lowest concentrations of the indicator substance in the air of the different locations in the valley basin.
Based on the results of the Landmonitoring-Study, the diffusion model developed by the University of Trento will be adapted to the effective values measured in the basin of Bolzano.
Grazie all'analisi dei campioni di tracciante raccolti,
Thanks to the analysis of the collected samples in the Eco-Research laboratories, it was possible to adapt the calculation model very precisely. This made it possible to precisely determine the distribution of emissions from the waste recovering plant within the Bolzano Valley Basin. The point with the highest precipitation, calculated over a year, is near the Sigmundskron Castle landfill. In terms of quantity, the area with the highest precipitation has a very low annual average of the various emissions near the ground. This is also proven compared to existing pollutants from other sources, 0.9% nitrogen dioxide and 0.08% fine dust.
Lo 0,9% per il biossido di azoto e lo 0,08% per le polveri fini.